Okay, so let's extend this further. Basically, we are going to go into further details of this rotational effects and move to a sphere. Okay, so just to repeat, we said when you have a rotational framework, then your U inertial is going to have a relative U rotation component and a component because of the rotation itself, which is omega cross r, right? And in that we are going to define this coordinate system with unit vectors x, y, and z, where the important thing to remember was that because the rotation, the coordinate system itself is in the rotating framework, it is rotating, which means it's not constant in time like the ijk that we are used to. So in this case, the d dt of the unit vectors x, y, and z themselves have to be considered from the inertial reference point of view, right? So again, it's like mother standing and watching you on the merry-go-round. So omega cross x is going to be that effect, omega cross y, and omega cross z. So we said that if you take a generic vector A, which is given by x hat ax plus y hat ay plus z hat az, then we can set A to be the distance r. So that's itself can be a vector. So you are moving along this direction with some relative velocity and a rotational effect. So from the inertial framework, then the total velocity is going to be u rotational plus omega cross r. This is very similar to what we looked at in the tank, right? We had capital V theta to be the inertial framework standing outside the tank and looking in. Small v theta was the motion relative to the tank, and omega cross r was the rotation of the tank itself. Very simple, no need to get confused. Now let's take A to be u inertial itself. Okay, that is going to be u rotational plus omega cross r. So A is u rotational plus omega cross r. So we can take d dt of u in just like we did d dt of A. That's going to give us du inertial dt in the inertial framework equal to d dt of the rotational framework plus the rotational effect omega cross u inertial, which is u rotational plus omega cross r. Haven't done any magic, it's very simple. So how do we solve this? You get d dt of u rotational, that's this term, plus d dt of omega cross r, which is omega is constant, so it's going to be omega cross d dt of r. What is d dt of r? That's just u rotational. So you get 1 omega cross d rho dt, or omega cross u rho t. Then you get the other term. You get omega cross u rotation. So you got 2 omega cross u rotation now. One from this and one from this. So you got 2. And then you got omega cross r. Sit down and solve it and make sure you understood it. Okay, this is very simple, so I'm not going to go split it and show it. So all we did here was to use d dt of r to be u rotational. Very simple. So the equation is du inertial dt in the inertial framework is that, and I'm showing it again to show that this is quite parallel to the water tank expression we had in the radial balance, where we said v theta squared over r, standing outside and looking at the tank, equal to v theta plus omega r squared divided by r, because v theta is that, which is just similar to this, and that expands to v theta squared over r, which is this term. 2 omega u rotational is this term, and this is this term. So here we have our rotational effect, and it turns out that this is the deviation because of the rotation that becomes critical on the sphere. Coriolis force deviates things from the direction of motion and that can actually give you some unique balances, like in the absence of friction and so on. Pressure gradient force can balance this Coriolis force and give you a very unique balance. For example, if you look at some weather charts, especially at mid latitudes, oftentimes you will see winds along constant pressure lines. That's pretty stunning. You expect flow to be along pressure gradient, but in a rotating system, rotational effect can balance the pressure gradient and actually give you flow along constant pressure lines. That's pretty amazing, right? That's what we get out of rotational systems and the rotational effects. That's what we have to get into our head, how to get used to these rotational effects in various phenomenon on ocean circulation and atmospheric circulation.